Okay, we're going to talk about the distance formula. I created a really embarrassing video about the distance formula when I was in college, and I dressed up and I sang it to a Bruno Mars song. So 10-point bonus for whoever can find that video. Just kidding, I don't think it's actually anywhere. But anyway, the distance formula is really fun. In my opinion, it is a way to calculate the distance between 2 points without having to draw a right triangle and technically use the Pythagorean theorem. But that is the plot twist because the distance formula is essentially the Pythagorean theorem. Basically what you have is you have 2 points that are some distance d away from each other. If those 2 points do not have a definite x1, y1 point, so if A is determined as x1, y1, and B is x2, y2, then the distance between A and B, the horizontal distance, is x2 minus x1. So for example, if x2 was just to say 6 and x1 was 2, the distance would be 4 because 6 minus 2 is 4. The distance between the vertical distance, so this distance right here, is the higher y value, so y2 minus y1. But it turns out that it actually doesn't matter which coordinate you call x1, y1, which one you call x2, y2 when you're using the distance formula. So the big question as to where does the distance formula come from? It comes from the Pythagorean theorem. So that Pythagoras guy, he really set up some cool things for geometry for you. Okay, and we can kind of see that because if I say that this length is A, and this length is B, and this length is C, well, A squared plus B squared equals C squared. If you take the square root, that's where that big old square root is coming from. So technically, your D distance is really just your hypotenuse. So you're trying to calculate the hypotenuse or the distance between 2 points. So you'll want to make sure that you write down this distance formula somewhere in your notes. It's also going to be given to you on your geometry formula sheet for the EOC or for any test. You're going to get that formula. So if we have just a basic, find the distance between 2 points. So we have 2 points, U and V. It does not matter which one is x1, y1, and which one is x2, y2, but the x1, y1 has to be married together and the x2, y2 has to be married together. So I'm just going to pick any old point to be x1, y1, and x2, y2. And from there, it's just plugging it in. You can plug this entire thing into your calculator. I'll show you how I kind of approach it, but it's going to be x2, so 4 minus a negative 7. So careful there. It's a subtraction between the 2 points. So if you're subtracting a negative, I'm going to ask that later, what do you think you get? And then y2 minus y1 squared. A lot of things that I see is I see kids missing that squared, sometimes writing it without it and then getting confused from there. So the distance is equal to the square root of 4 minus negative 7, which becomes 11 squared, plus negative 3 minus 5, which is negative 8 squared. Okay, and then we have that 11 squared is 121 plus 64. You are never going to have a negative number being added to a number because when you square a negative, you got it, it makes a positive. So I'm going to move this up here. That becomes the square root of 184. And if we want to round to the nearest tenth, again, that's 1 decimal point. That's going to give us approximately 13.6. Okay, so this should be pretty simple just to be able to plug in points into the distance formula and solve. Things that you sometimes forget on your calculator, you might forget the squared. You also might forget the negative. Just make sure you type it in and you write it out first before you actually put it in your calculator. All right, this next problem I think is really cool. So it says, use the subway map to determine the total distance from Cedar Station to the Symphony Station. So we're going from Cedar to Symphony, but the train can't go off the track, so we have to follow this green path all the way to City Plaza and then go from City Plaza to Symphony. So there are 2 different distances that we have to calculate here. So we have to calculate Cedar to City Plaza, and then we also need to calculate City Plaza to Symphony. Okay, So I have to identify what is Cedar's point. It's -3, 1. And City Plaza is 0, 0. And then for my distance formula, I've got -3 minus 0 squared plus 1 minus 0 squared. That's ultimately going to give me the square root of 10. And if I round to the nearest tenth, I will get 3.2. Doesn't exactly tell us what it is, but let's just call it miles because we want to make sure that we're using units whenever we're calculating distances between points, if we can. So then now from City Plaza, so that's a 0, 0, to Symphony, which is 1, 2. Okay, I'm using my distance formula again, so I'm going to call 1, 2, x1, y1, and 0, 0, x2, y2. So it's going to be, actually I'm going to do it the reverse. So 0, 0 is going to be x1, y1, and 1, 2 is going to be x2, y2. So that's going to be 1 minus 0 squared plus 2 minus 0 squared. That's going to end up giving me the square root of 5 equals 2.2. So just to kind of identify where those distances are, we have 3.2 is the distance from Cedar to the City Plaza, and then City Plaza to Symphony is 2.2. So the entire distance is those two distances added together, 5.4, let's call it miles. So that's a really easy way to lose points on a quiz or a test is by not using your dimensions. All right, this next one is kind of interesting. So quarterback throws a football from a position that is 10 yards from a goal. So when I am approaching these word problems, I always just draw one step at a time. So that's my horrible goal line or touch, whatever. All right, so the quarterback is 10 yards from the goal. So he's like here. So this distance right here is 10 yards. And he's 15 yards from the sideline. So he's 15 yards from here. Well, his receiver is catching a ball and he's 50 yards from the same goal line. So from this yard, he's 50 yards now. So I'm going to use a different color to help us out. So his receiver is 50 yards. Okay. And he is 5 yards from the sideline. So we have a little bit of them are both out in the playing field, and we kind of have to do some subtracting to identify. So this is actually a throwback. You get it? Throws a football, a throwback. It's a throwback to the Pythagorean Theorem that we talked about in the earlier video. So we have, this is the triangle. I don't know if you can see it, but let's say we zoomed in. This is the diagonal from the quarterback, and then we have the triangle here. So if he's 15 yards away, if the quarterback is 15 yards away and the receiver is 5 yards away, then that means that the distance between the two from the sideline is 10 yards. Okay, and if the receiver is 50 yards away and the quarterback's 10 yards away, that means that they are 40 yards away from each other. And I'm trying to find the hypotenuse between the two football players. Okay. So again, throw back to the Pythagorean theorem, we're using a squared plus b squared equals c squared. Okay, a squared doesn't matter which one you choose to solve for a, which one you choose to solve for b. C is the hypotenuse, so that's my highlighted blue line. So 10 squared plus 40 squared equals c squared. 10 squared is 100, 40 squared is 1600 equals c squared. It seems really large, but when we take the square root, it's going to get significantly smaller. So 1700 equals c squared. Take the square root of both. C is going to be 41.2 yards. That is going to be a touchdown. Go Dogs. Okay. So again, using your dimensions. Whenever you're approaching an extension question that has this longer wording, just draw every step as you interpret it. Sometimes I like to read it all the way through first, and then I'll read it step by step in order to draw it. All right, good luck.